Hello everybody. In this video, what we're going to do is we're going to start off where we left off in the last video. And what I'm going to do is I'm just going to go ahead and define some of these types that we had created earlier. But I'm going to do this right now on my shell, on my Haskell's Glasgow compiler shell here. And so I'm going to say let's create the first one, which is basically my suit, which is going to take on the four possible values: a heart, a diamond, or a spade, or a club. And this basically takes all the behaviors from the type class show there. And let's do the same thing for a playing card. So a playing card can take on these five possible value constructors. I have an ace of suit, it could be a king of suit, or it could be a queen of suit, or a jack of suit, or this could be a value card which takes in an int and a suit, and this also takes on the behavior from the show type class. Okay, so let's just go ahead and create one such card here. So let's say I want to create this card over here which has the number 6, and this belongs to a diamond. So I want to create basically a 6 of diamond there. How would I do that? So let's create a card here. Let's call this that card 1, and this is going to be equal to a value card that has number 6, and this happens to be a diamond, and that's it. So if I look at my card, if I look at the type of my card 1 there, well, card 1 is basically of a type playing card. It's a type playing card there, which happens to have a value. It happens to have a value of 6 of a diamond. How would I create a card? How would I create a card that's basically, in this case, a jack of heart? To create a card that happens to be a jack of heart, I'm going to use my value constructor. Which is a jack of suit there. So I'm going to say let card 2 equals to jack of suit there, and this is going to be, in this case, let's say heart. Okay, likewise, if I ask Haskell what's the type of card 2, I get back to the type of card 2 is a playing card, and the actual value that's contained in in card 2, the actual value is, in this case, a jack of heart there. Okay, now let's try to extrapolate this problem a little bit further, where I just don't want to create each one of these individually because I have a total of 52 cards. Could I use some of these approaches that we've been looking at in functional programming to put together a list of cards that basically uses tail recursion? So what I'm going to do now is I'm going to keep my first shell over here. Let's just keep the first shell right there, and I'm going to bring in my second shell, which is right here. Okay, and let's just step through this problem here. So I've already got most of the code written down there, and we're just going to step through this to see if it actually makes sense. So first thing, let's just let me just get my drawing utility. So let's get the drawing utility, and let's see this. Let's open open. Oh, there you go. This is right here. Okay, so let's get this a little bit on the side. Okay, it doesn't want to come on the side. That's all right. And let's see the first part. The first part is pretty straightforward. I've already shown you this on my last video. So this is nothing but the code that puts together two types, suit and a playing card. Now, what I'm proposing here is that in this solution that I'm trying to generate a deck of playing cards, I have my variable here, which is deck of playing cards, which is eventually going to contain a set of 52 cards there. So just to put some notations there, this deck of playing cards has a certain type. It has a certain type, which is a list of playing card, and the way I'm going to generate this is I'm going to use tail recursion. So I'm going to make use of a helper function. Okay, I have a helper function here, and this helper function is called deck of playing cards prime. I'm using the prime notation to signify it's a helper function there, and I'm going to use my where bindings. I'm going to use my where binding where I'm going to define what exactly is this helper function really doing. So this helper function takes in a set of 3 parameters. It takes in as a first parameter all the possible values, all the possible, in this case, all the possible value constructors. But keep in mind that what I'm doing here is I'm intentionally not passing in the value constructor called a value card, and you're going to see that in just a second. Why am I doing that? So I'm going to pass in my value constructor ace, my second value constructor king, the third value constructor queen, and the fourth value constructor jack. I have all my 4 value constructors there in a list, and my second list over here basically contains all the 4 possible values that a suit can take. So I've got my heart, my diamond, my spade, and my club. And the very last parameter over here is basically my accumulator. And the very first time when I call my helper function, the accumulator is empty because I haven't yet generated any playing card. I don't have any playing card at this time, so my accumulator is empty at this time. Okay, and the whole idea now is that as this tail recursion starts executing, what I'm going to do is I'm going to exhaust my entire first list that contains all these value constructors. So this list over here, which is originally ace, followed by a king, followed by a queen, followed by a jack. What I'm doing here is as part of my pattern matching over here in my recursion, V in this case basically at the first time it basically points at an ace. Alright, so ace over here is basically my value constructor, and because it's my value constructor, what I'm doing here is let's come back to in just a second. I'm just going to come back to the implementation in just a few moments, but kind of zooming out from this problem here, I'm going to make sure that each one of these gets taken off from this list. At some point this list will get reduced to king, queen, jack, and at some point as I keep on drawing elements out from this list, it's going to become an empty list. And when it becomes an empty list, which is right there, when it becomes an empty list, I've hit my base case. And what I'm going to do in my base case is I'm going to intentionally create all the possible set of cards that can be generated using the value card constructor. Okay, so all the possible value card constructor, which is this list here, which is this entire piece in blue, this entire piece in blue. Okay, this entire piece in blue over here is going to get generated in my base case. And the way I do that is I'll run my first list, which goes from 2 to 10, which is for all these numbers from 2 up to 10. And as I do that, I'm going to go across every single suit for spades, heart, clubs, and diamond, and I'm going to invoke my value card value constructor, which has a type, which has a type signature. It has a type signature of something that goes from an integer to a suit. Okay, you won't be able to see that, so let me just put this piece over here. So value card has a type signature that basically goes from an int to a suit and gives you back a playing card. Okay, and that's exactly what I'm doing here. I'm basically drawing all these entities out from my to list here, and I'm invoking my value card value constructor, which takes in an integer, it takes in a suit, and it generates back to you this entire list that contains of all these elements in blue here. Everything in blue over here gets generated by this base case. And then whatever is the accumulator at that point, meaning this accumulator at the time should be these cards in red here. So is this entire first column there, which are my aces for spades, hearts, clubs, and diamond, and these last three, the last 3 cards in every row there. Okay, so 3, 6, 9, 12, 13, 14, 15, 16. All these possible 16 cards will be collected at the accumulator when the base case is called. And whatever is the accumulator, I'm just going to do a concatenation, a list concatenation with all these other cards that are generated there. And that's it, and that's what my solution is. So let's quickly look at the recursion case. And in the recursion case, what's happening here is the idea that I'm invoking here is that for every single suits, where suits happen to take these values of heart, diamond, spade, and club, I'm just going to draw each one of them, and I'm just going to call my value constructor, which is V, where V is basically going to be either an ace, or a king, or a queen, or a jack, and so forth. I just invoke my value constructor on every single element on that suit. So again, if you want to just do a quick recap here. Map in Haskell is defined as a function that goes from A to B, where A and B could be anything. It then takes in a list of A's. It then gives you back as a value, as an output, a list of B's there. This V over here is acting as this function that goes from A to B. Likewise, the suits over here is basically my list of A's. More specifically, this list of A's over here happens to be my list of suit there. Okay, and this function A to B is basically my V there, which is basically my value constructors, which could be either be an ace, or it could be a king, or it could be a queen, or it could be a jack. Okay, and what this map does is going to draw every single element from that list of suit. So it's going to draw out a heart, a diamond, a spade, or a club. But as it draws them, it's going to apply that function that goes from A to B on that element that just got drawn out from that list of suit. So this is going to be an ace of the very first one is going to be ace of heart. Then you're going to have ace of diamond, ace of spade, and ace of club. So this function ace, which is in this case V, the first time when a recursion case hits, right, is going to apply ace on every single suit, and you're going to get back as an output a list of B's, but the list of B's in this case is going to be a list of playing card. It's going to be a list of playing card. Okay, remember this A over here is basically my suit, this B over here is my playing card, and what I get back as an output is my list of B's, where this happens to be a list of playing card, Well, this is really great, because once I've got my list of playing cards, which is entire piece is my list of playing cards, I'm just going to do a list concatenation with whatever is the accumulator at a time. I'm just going to do a list concatenation, join them, and that's my new accumulator, which just passed in again recursively, or in the base case when I call deck of playing cards prime again at a time here. And in my recursion, as you can see, the first parameter does get reduced and does converge towards a base case. So V crest over here is basically these whatever is remaining as my value constructors in my list at a time, and it gets passed in again recursively into deck of playing cards prime. And suits over here is basically something that doesn't change here. So if you look at this piece over here, the suits over here, which is my list of all possible suits here, just keeps on passing, gets passed directly into the base case right there, and it gets passed also in my recursion case, and I just simply draw elements from that list whenever I need to do that. So I hope this is useful in understanding some of these concepts as to how am I using tail recursion in putting this solution together. And what we did in the lecture was used something very similar, but we just used entirely a solution that was built using list comprehension. And anyways, that's all I had for today. I just wanted to make sure I get something out for you folks before you sit for a quiz tomorrow. So anyways, I hope this is useful, and thank you.